Good morning, students. I am going to teach about microprocessor microcontroller for third EC students. So first, microprocessor and microcontroller. What's my microprocessor? Microprocessor is a programmable semiconductor device which fetches, decodes and executes the instruction. So this is called microprocessor. So then another one definition. The microprocessor is a programmable IC which are capable for performing arithmetic and logical operation. So this is also called microprocessor. Next, microprocessor is a CPU. So this is a microprocessor. Then another microcontroller. What's my microcontroller? So microcontroller means CPU addition with it consists of RAM, ROM, IO ports, serial ports, timer counter. So this is called microcontroller. Next, what is the difference between microprocessor and microcontroller? The microprocessor, the CPU. Microcontroller, CPU with addition, it consists of RAM, ROM, IO ports, serial ports and timer counter. Then another one difference, so microprocessor is a general purpose applications. Microcontroller special purpose application. So because in microcontroller special function registers are used, so it is used for the special purpose application. Okay. Next, unit 1, microprocessor, the basic microprocessor architecture. So this diagram indicates the basic functional blocks of microprocessor. Okay, so what are the basic functional blocks? ALU, registers, program counter, instruction register and control unit. Okay, first ALU. ALU means arithmetic and logical unit. Okay, so it performs arithmetic and logical operations. Okay, for example, arithmetic operations means addition, subtraction, multiplication and division. So logical means AND, OR, XOR, gates. Okay, these are the examples for logical operations. Next, registers. R1, R2 and Rn indicate the registers. So it is the internal storage device. Yeah. So R1, R2 and Rn indicate the internal storage device. So it is the internal memory. It is also called internal memory. Okay. Next, instruction register. Another one is the instruction register. What's in the instruction register? When the instruction is fetched from memory, it is located in the instruction register. Next, program counter. Okay, another one is the program counter. It is also register, 16-bit registers. Okay, here the function of program counter is that contains the address of the instruction being executed at the current time. Okay, this means it's a register that contains the address of the instruction being executed at the current time. So it is the program counter. Then another one, control unit. So control unit generate the control signals. The control unit generate the control signals for internal external operation for the microprocessor. Okay, so this diagram is the basic functional blocks of microprocessor. Clear? Okay. Next is the architecture of 8085 microprocessor. Okay, so this is the architecture of 8085 microprocessor. Here, first, already we discussed the basic functional blocks is first one is ALU. See the diagram? See the diagram? Here, it is the ALU. That means, okay, this part is the ALU. So it is the 8-bit register. It will perform arithmetic and logical operation. Okay. Then another one, accumulator. Okay. So accumulator. So it is the 8-bit register. It is also called A register. Okay. The function of accumulator is to hold the data during arithmetic and logical operation. Clear? Okay. This is the accumulator. Then next one, temporary register. So this part is the temporary register. It is a 8-bit register. It is not used for the programmable purpose. Understand? Prida? So temporary register is the 8-bit register. It is not used for the programmable purpose. Next, flag. So flag means it's a flip-flop. It is also register to store the information of the status of the processor. It's clear? Okay, flag is a flip-flop to store the status of the processor. Okay, next there are 5 types of flag in the 8085. Sign flag, zero flag, carry flag, auxiliary carry flag, then parity flag. Clear? So important 2 more question. How many flags used in the 8085? There are 5 types of flag. Sign flag, zero flag, carry flag, auxiliary carry flag, and parity flag. Next, instruction register. This part is the instruction register. So it is the 8-bit register. When the instruction is fetched from memory, it is located in the instruction register. Next part here, these are the registers. Okay, so here B, C, D, E, H, L. So these are the registers. If it is combined, it is called a register pair. Okay, each register consists of 8-bit registers. For example, B register is the 8-bit register, C register is the 8-bit register. Okay, so if it is combined, it is called 16-bit register or register pair. Clear? Okay, so these registers are called general purpose registers. Okay, what are the general purpose registers? B register, C register, D register, E register, H register, and L register. Next is the stack pointer. What's in the stack? Stack is the sequence of RAM memory location. Stack is the sequence of RAM memory location. Okay, so it is the 16-bit register. Next one, program counter. So program counter means, so it is a 16-bit register. It contains the address of the instruction being executed at the current time. So it is the program counter. Okay, so upon AL, so first functional block, the first ALU, next instruction registers, then registers. Next, another one part, timing and control unit. So what are the function of timing and control unit? To generate the timing and control signals. Okay, so here see the diagram. Control. Here control signals. What are the control signals? Read, write and ALE. Next, status signals. So status signal indicate the X0, X1. Then DMA, direct memory access signals, hold and hold acknowledgement. Next, reset signals, reset in and reset out. These are the timing and control unit. Okay, so what is the function of timing and control unit? To generate the timing and control signals. Okay, clear? Next, interrupt. Another one important part is the interrupt. What's in the interrupt? Interrupt is the breaking the sequence of operation. So how many interrupts in 8085? Interrupt request, see the board, see the diagram. Interrupt request, interrupt acknowledgement, then RST 5.5, RST 6.5, RST 7.5 and trap. Okay, these are the interrupts used in the 8085. So trap is the highest priority of interrupt. Okay, in 8085, trap is the highest priority of interrupt. Next, RST 5.5 is the lowest priority of interrupt in 8085. Next, here this section is the serial input and output control. Here, this pin indicates the serial input data. This pin indicates the serial output data. Okay. Next, the features of 8085. It is the 8-bit processor. Okay, it is the 8-bit processor. Next, here the clock, internal clock frequency 3 MHz. Okay, these are the features. Then it operates. It consists of 8-bit data bus and address bus. Next, here in the 8085, there are 3 types of buses. Bus means it's a group of conducting lines. These are the buses. So, bus means group of conducting lines that carries data, address and control signals. Clear? So, data bus means the data carries between processor and other components. Clear? So this is a function of data bus. Next, address bus means the address carries between processor and other components. So address bus. Then third one, control bus. So control bus means to carry the control signals between processor and other components. Clear? So 3 types of bus used in the microprocessor. The 3 bus: data bus, address bus and control bus. In 8085, 8-bit data bus, 16-bit address bus. Okay, here this pins, that means ALE. It's an important pin, ALE. That means address latch enabled. So address latch, what's the function of address latch enabled? So ALE is the function is to demultiplex the address and data lines. Okay, so these are the architecture of 8085 microprocessor. It's clear? Thank you.